Right, this is part 2 of the Chapter 4 test. In this part of the video, you're going to see some more things that you might see on the second half of your test. So first thing we have is 10 cubed, or 10 to the third power, times 0 and 29 hundredths, or 0.29. Now, we know that when we multiply by a 10, or a product like 10, 100, 1,000, we know that we don't have to stack them on top. We know that we can do our special secret method of when we move our decimal to the right, however many places it tells us to. However many places it tells us to is what the power is up here, or if it's written out like is 1,000, for instance, we count how many zeros. In 1,000, there's 3 zeros. But this time it's written as 10 cubed, 10 to the third power. So that means I'm going to move my decimal 3 places to the right. Because when I times something by 10, my number gets bigger, so my decimal is going to have to move to the right. So let's go ahead and do that. 1, 2, 3. I have this big open spot right here behind the 9. Whenever I have an open spot, I have to plug in a 0 because something needs to hold that place. I'm going to plug in my 0 and I'm going to rewrite my equation correctly. I got 290.0. I could say just 290, take off that 0.0, or I could have the 0.0 there. Both numbers are equivalent. Next, I have 10 to the 0 power times 0 and 29 hundredths. Same thing. We can use our trick of moving our decimal to the right because we're timesing by 10. Well, how many times are we going to move it to the right? 0 places. So 0 places meaning I'm not going to move it at all. So I'm just going to rewrite my equation as 0 and 29 hundredths. All right, let's move to the second half of what we're going to work on. What if I had an equation that looked like this? (75 hundredths) times 1 and 4 tenths. Well, we know that when we multiply decimals, all we're going to do is throw away the decimal, stack them on top. So we're going to take our 75 times our 14. And we're going to multiply them just like normal. We worry about that decimal at the very end. So first I have my 4 times 5, which is going to give me 20. Then I have my 4 times 7, plus 2 gives me 30. Add my 0. 1 times 5 is 5. 1 times 7 is 7. I add them up. 3 plus 7 is then going to give me 10. Now here's where the decimal comes in. I'm going to look back at my equation and I'm going to count how many numbers are behind the decimal. 1, 2, 3. That means I need to move my decimal up 3 places. Right now it's imaginary, it's way back here, and I'm going to go 1, 2, 3. Now I have to rewrite my new answer, which is 1 and 5 hundredths. I could write my equation like this, or I could write it like this. Both answers are equivalent to each other. They both say the exact same thing. Both would be correct. Next. What if I had the equation 6 and 32 hundredths times 15 hundredths? When I multiply decimals, I throw away the decimal, I stack them on top. My bigger number goes on top, which will be 632 times my 15. Now I go through each one. 5 times 2 is 10. 5 times 3 gives me 15 plus 1 is 16. Now I have 5 times 6, which is 30, plus 1, 31. Add my 0. 1 times 2, 2. 1 times 3, 3. Then I have 1 times 6, which is 6. I add them up. 6 plus 2 gives me 8. 1 plus 3 gives me 4. 6 plus 3 gives me 9. Now I got to figure out, where does that decimal go? I go back to my equation, count my decimals. 1, 2, 3, 4. 4 numbers are behind the decimal. That means I got to move my decimal up 4 places. 1, 2, 3, 4. Now, I'm left with this number right here. The most proper way to write this number is to throw a 0 in front. If you forget the 0 in front, no big deal. I would take this, I would take this, and I would also take this or this. There's a couple different variations you can write this answer, and I would still count it correct. But if I had to say which one I think is the perfect way to write it, I would say this last one right here is the absolute best way to write it. Best way, but any of those I would still give you credit. Next, let's do a word problem. An ice rink charges $203 per hour for parties. How much would a 2.5-hour party cost? So the party is going to be 2.5 hours, and I want to know, if I'm going to have a party for 2.5 hours, how much is it going to cost at the ice rink? Well, first thing I'm going to have to do is multiply my two numbers. When I multiply my two numbers, throw away the decimals, stack them on top. So that would be 203 times 25. I have my 5 times 3, which gives me 15. 5 times 0 is 0, plus 1 is 1. Then I have 5 times 2, which is 10. Add my 0. 2 times 3 is 6. 2 times 0 is 0. 2 times 2 is 4. Now I add them up. 1 plus 6 is 7. 0 plus 0 is 0. 4 plus 1 is 5. Same thing, I go back to my equation, and I see how many decimals are going to be in my equation. So if we had 203 times 2.5, I'm only seeing one decimal here. So I'm going to go back to my answer and move one spot, rewrite my number, 507.5. But if I think back to my problem, it's talking about money here. They want to know how much money it's going to cost for this party they're talking about. Well, if I got this answer, now I need to change it to money. So, of course, I'm going to put the money sign in front. And then I'm going to look. $507.5. The change always has 2 spots. And that 5 is in the tenths place, meaning 5 tenths. If I have 5 tenths, that means 0.50. So that means that my party is supposed to be $507.50. So here I have to plug in my 0. Because when I'm doing money, I need to make sure it's written in the correct form. So if it was just a decimal number, yeah, I could leave off that 0 at the end because it doesn't change the amount. But when I'm talking money, I need it in the correct form. So I have to have it right here where my cents have 2 spots. All right, guys, well, I hope you studied this video and part 1 and you get ready for your chapter 4 test.